All right, guys, welcome back. If you just watched the outline tutorial, this is your first tutorial. I'm going to give you some help, and where I'm going to give you some help now is once you have your outline finished, where do we go from there? How do we take our answer, our evidence, or proof, and our explanations and put them together into a nice, neat paragraph? Well, I like to use something called the 3.8, and I'm going to show you an example of how you put a 3.8 together with the APE format. I know that sounds like a bunch of crazy words, but trust me, it works. And so this is where eventually you'll be typing your own, but before you type your own, why don't you check out my example here. And so we are going to start with this example. It says how to organize an APE response. And again, here's our question, the haunting question, except for this one, we're going to use a different chemical reaction. And this is a reaction between hydrogen and oxygen. That would be 2H2 plus O2 yields 2 in a blank molecule. Here is the outline form for how I figured this out. Again, we always want to start with our answer. And so the answer to this one, and I'll actually we'll talk you through it, how I figured out this one. Here's your drawing. The answer to this one is 2H2O. And how do I figure that out? Well, let's talk about it. We'll fill it in once we're done. Because my job now, just like your job is to prove to me, is to prove to you that the answer here is 2H2O, just like ours. So the first proof that I'm using is the law of conservation of matter. I put the proof in green because it's going to be separate from when we explain our proof. We're not just going to list our proof. We're going to pick the key important proof. We're going to list one, then we're going to explain. So check it out. This is how it goes. Proof 1. The law of conservation of matter states that matter cannot be created or destroyed, only rearranged. I decided to start with the law of conservation of matter because number one, it's the most essential learning from this activity. But number two, it sets the stage and gets us ready to be able to explain how it is that we figured out what the missing molecule was here. And once I give a piece of proof, I need to explain to my reader what that proof means or why I used it. And so that's when I drop down to explaining my proof, which is explain proof 1. And as you can see, it says matter is made up of atoms, which means that atoms cannot be created or destroyed in a chemical reaction. In other words, the type and number of atoms that are in the reactants must be rearranged and used to make the products for the reaction. So check it out. I gave the law of conservation of matter, and then I explained why the law of conservation of matter matters for this particular question. It matters because matter is made of atoms. And if matter is made of atoms and it can't be destroyed, then that means that atoms can't be created or destroyed in a chemical reaction. So now I need to start moving towards my answer. That's when I'm going to give proof number 2. And proof number 2 is me counting up the atoms in the reactants. So here's how I did that. It says the reactants have 4 total atoms of hydrogen. Well, I went up here and I looked to the left of my arrow and I found my reactants and I counted 1, 2, 3, 4. That's a great proof, but it's also very similar to the other proof, which is that there were 2 total atoms of oxygen. 1, 2. The products over here will be made up of 2 molecules, and I know that because of this number 2. But we do not know what these will be just yet. And so I need to explain myself because I've given proof, but the reader doesn't really understand why I'm using it. So I say explain proof 2. Since there are no products yet, the 4 hydrogen and 2 oxygen in the reactants will have to be in the products. Also, there is a 2 in front of the missing molecule. I need to explain that, meaning that there are 2 molecules missing. Okay, now the reader understands a few things. Let's recap. They understand that I'm claiming that the answer is 2H2O, but they don't believe me. I have to prove it. The first proof that I'm giving is that the law of conservation of matter states that matter cannot be created or destroyed, only rearranged. Why did I do that? Well, because matter is made up of atoms, which means that atoms cannot be created or destroyed in a chemical reaction. In other words, the type and number of atoms that are in the reactants must be rearranged and used to make the products for the reaction. Then I gave my reactants. There's 4 total atoms of hydrogen and 2 total atoms of oxygen. The products will be made up of 2 molecules, but we do not know what they will be yet. Since there are no products yet, the 4 hydrogen and 2 oxygen atoms in the reactants will have to be in the products. Also, there is a 2 in front of the missing molecule, meaning there are 2 molecules missing. Okay, now I'm ready to give them how I figured out my final missing molecule. So I give one last piece of proof. 2 molecules of H2O are composed of the same, composed means made up of, composed of the 4 missing hydrogens and 2 missing oxygens. Well, that's great, but I have to explain why that's important. Well, it's important because the reaction now satisfies the law of conservation of matter. It doesn't break the law. No matter was created or destroyed because the atoms broke apart. Ooh, that's not quite right. Let's fix that. The molecules broke apart and the atoms rearranged to form the new molecules, and the number and type of atoms are the same in the reactants and products. The missing molecule is indeed H2O. In order to fix this over here, I'm going to do this real quick. Now, notice that I've gone back and reread my evidence or my proof and how I explained that proof before I did the next one every single time. Why do I do that? Think about that for a second. If you're thinking the reason that I do that is to make sure that it all makes sense, you are thinking correctly. If you're thinking the reason I do that is because I like to read, well, I do like to read, but I don't like to reread my own work all the time, only when it matters, and it matters right now when you're typing up your final answer. So check it out. I kept it color-coded, but this time I put it in paragraph form, and we'll read it one more time. And I want you to listen to how this sounds. Listen to the order and the logical steps that I take to get to the answer. So lead with your answer. The missing molecule was 2H2O. The law of conservation of matter states that matter cannot be created or destroyed, only rearranged. Matter is made up of atoms, which means that atoms cannot be created or destroyed in a chemical reaction. In other words, the type and number of atoms that are in the reactants must be rearranged and used to make the products for the reaction. The reactants have 4 total atoms of hydrogen and 2 total atoms of oxygen. The known products will be made up of 2 molecules, but we do not know what they will be yet. Since there are no products yet, the 4 hydrogen and 2 oxygen atoms in the reactants will have to be in the products. Also, there's a 2 in front of the missing molecule, meaning there are 2 molecules missing. 2 molecules of H2O are composed of 4 missing hydrogens and 2 missing oxygens. The reaction now satisfies the law of conservation of matter. No matter was created or destroyed because the molecules broke apart and the atoms rearranged to form the new molecules, and the number and type of atoms are the same in the reactants and products. The missing molecule is indeed H2O. And if you want to see it for yourself, I can now get rid of this box. Get 4 of these. Get rid of that.